Okay, good morning. So I'm the warm-up act for Peter and Jonas, who are going to be talking in a little while. I'm not sure whether they'll be joined by Lars or anybody else. Yeah, okay, Lars as well. Talking about mainframe migration projects, and I'm going to try and warm you up to that by talking about one of the many components that they used in at least one of these projects, which is the Dyalog File Server. So I'm going to try and tell you what it is. I'm hopefully going to be able to motivate why we did this project. Give you a quick demo, of course, and then talk a little bit about how you operate this thing, talk a little bit about performance and the differences between what we're now calling DCF versus DFS, Dialog Component Files versus the Dialog File Server. Though, of course, one of the designs of this project is that there should be no differences between the two when you use them. And then finally, a bit about the road map. So what is the DFS? It's intended to be a plug-compatible replacement for the existing component file system. So it's something that you could slot in, and your application will continue working with no changes, perhaps, when we're finished with this project, and initially very small changes to get going. And the way that it's different from the existing file system is that it's a client-server system. So instead of accessing the component files over the local area network as operating system files as seen by your client environment, you're actually communicating using TCP/IP to some server processes that are running on a box. Could be on the same machine, could also be on the other side of the world. Although the access mechanism is different, the underlying technology is Dyalog, regular Dyalog component files. So the files that are being used by the server are the same files that you use today. So the architecture of this system, I hope this gives you some idea of how it works. The yellow things over here are various types of clients, mostly APL client applications. And then the DFS consists of a number of processes which at the moment all need to run on the same box, but after a release or two will be able to run distributed across a variety of machines on the server side. The dark gray boxes are the ones that are doing most of the work. These are processes that are actually opening files and performing read and write operations on your behalf. But then there are a couple of other components. There's a master server that's handling logons, security. There's a separate locks server which is handling all the file holds and locks for native files. And then there's a monitor that provides a web interface based on my server so that you can manage this whole complex. Right, and since this is an APL audience, before I describe all of the workings of this, I'm going to try and give you a quick demo so you get a feeling for what this is. And then it'll hopefully be easier to understand or put the rest of the slides in context. So I've loaded a workspace in which we have this class called DFC, which is the Dialog File Client. And at the moment, we don't have the quad functions don't give direct access to the DFS. You have to use this class. You have to create a new instance of it, giving parameters describing how to connect to the server. So it's the machine and the port number that it's running on. And if you're using integrated Windows authentication, which means you want to log on with the Windows credentials that you already have, you just put this IWA as the third argument. And you see, it's not connecting to the server. And the reason for that is that the server is not running. And with a bit of luck, I'll be able to start it. So this looks very much like a My Server workspace, which in fact is exactly what it is. So I'm going to switch from looking at the weather forecast to the DFS monitor. This is what the monitor looks like. And if I want to do anything, the best results on my machine are if I tell it I'm Brian Becker. And that's a user ID which doesn't have Windows authentication on this machine, so I'm going to tell it this is a special login that the DFS knows about, and then I click on the Start DFS button. And within a few seconds, this is where I should have had a joke prepared. It's all going, startup completed, it says, and if I now return to the original session, I can click retry now, and I have one of these client objects. And I can then ask it, for example, I can ask for a couple of properties that it exposes. So what's my user ID? I think so. A little bit more. Is the size okay? Oh, okay. Sorry? No, I logged on to the monitor as Brian Becker. This is a client logon from my APL session where I logged on as whatever user ID I'm logged on to on Windows already. And that happens to be this mcrom user ID. So in addition to the Dyalog component file functions, there are a couple of additional functions that come from SHAREFILE that are copies of SHAREFILE AP functions. I mean, this whole DFS project is very similar to the old mainframe client-server file systems like SHAREFILE AP, like the SHARP APL file system. They worked in this fashion. And one of the motivations for doing this project is we have a number of people who want to migrate off mainframes. Many of them are using SHAREFILE AP. So that's why we've added that support as well. Yeah, okay. So you can see the syntax here is very, if you name the client Q, then you get a syntax which is very close to using quad functions. So you just put a Q dot. And so, in fact, in your application, if you wanted to transition to using this, then the big change would be use fire or something like that, replace all quad F's by Q dot F, and you need to add a login statement somewhere, and you're up and running. So, I'm not going to demonstrate all of the file functions. I think that's unnecessary. But here's another one, another function that was added from SHAREFILE AP, which is also now supported by the DFC. So there's a quad fhist that you can use from 13.1, which has the same syntax as this. One of the nice things we can do, since we're writing APL code here, most of this is implemented in APL, is we can add little utilities to our file interface. So we have the FTT function, the file timestamp file to TS, and I can convert those file system timestamps into something I can easily understand. There's also a user command I should remember to point out. If you're not using the DFS and you need to convert file timestamps, there is now a user command to do that. You can read components. One thing which is optional is that because the system understands about user IDs and user numbers, you can optionally request that all the places where you have a function that would have returned a number now returns a user name. So you can see the last person who updated this, it says is Brian, which is a character vector rather than a numeric integer. But if that doesn't suit you when you do your migration, you can elect to have the numbers instead. If you try and log on with a user ID that isn't recognized, it signals an error. One of the fundamental differences that some of you might benefit from is that, you see, I created a new client here. I still have the old one. So I can now make more than one connection to the file system. And in fact, I can use them independently. They have independent sets of tie numbers. I can fhold independently. So I could have two APL threads independently using the file system without conflicting with each other's user tie numbers, etc. So the Brian user also ties a file. I can fhold it. And I now have the hold. I'll update a component. And then Brian, oops, maybe that was a mistake. The good news is that one of the features of this monitor is that, well, first of all, we have this page which allows us to see all the sessions on the system. So we can see there's the monitor connection. There's the Brian's monitor connection where he logged in to be a monitor. This is just a background monitor task. And then there are the two tasks that I logged in as. We can see what file ties exist. So there's this file here, which is tied both by Morten and Brian. And I can see who's holding files, and I can also see who's in the queue for holding a file. So I can see that Brian is blocked here because Morten is holding the file. And he's had that hold for a minute now, which is unreasonable. So I'm going to kill him. Bang. Isn't that useful? And now you see, without my typing anything else now, Brian has the hold. And Brian can replace the component. And then when Morten tries to do the next operation, he gets a couple of error messages, because what happened was the TCP socket was just closed by the server. So you get a couple of error messages here saying the socket was closed. Then it tries to automatically reconnect, but because it had a hold, the reconnection operation is illegal. Under all other circumstances, even if you have files tied, you can reconnect to the server and just continue operations. So if the network goes down, if you hibernated your machine, took it home for the night, came back the next morning, turn it on, you automatically reconnect, except in the case where you had file holds, because in that case you were in an invalid state, essentially. And if I expunge these variables, the wonderful object-oriented destructors click in, and if I refresh the view here, we can see that the users are gone and the holds are released, etc. So just by expunging these connections, you log out of the file system, close the files are closed, etc. Okay, so back to this picture very briefly. What's happening is these clients are making connections to the various servers that they require from time to time. So each client is not necessarily connected to all the services. The file system can be configured so that you're running a bunch of processes on the server side, handling different parts of the file system, so that you can get some load balancing going. Right, so the features of this system are the dialog component file functions, all of them, I believe. A few SHAREFILE AP functions that the people who've migrated so far needed. We've decided so far not to add the numeric library feature that some of these older file systems have. So you're using folder names. But I think that's pretty easy to emulate if you're doing a migration on the client side. What might be a bit of a surprise is that the DFS also supports native file operations, so you can open flat files and read and write them. And I'll get into the reason for that in a moment when we get to the justification of this. And then there's additional file and folder utility, so create directory, copy files, move them, etc. And then, of course, the management console, which is something you don't have with the existing file system. And the implementation of this may surprise you. It's virtually all written in APL. Fully salted, which is very, very good, and completely object-oriented, and the jury's still out on whether that was wonderful, but we're learning to love it. Some extensions to the TCP layer and the component file system were required. For example, we had to add this support for integrated Windows authentication, so the transmission of your client credentials to the server side so it can validate and be sure that it knows who's at the other end. And then some support for allowing a single server task to impersonate a large number of users so that the FRDCI information, for example, is correct, even though there's a single server-side process doing this. We do expect that to increase the performance, we will gradually rewrite more pieces of this in C, but we definitely want to keep the core in APL because it allows us a lot of flexibility and things like allowing you to put APL-coded stored procedures on the server side of this, which is something that I think could be used to dramatically enhance the performance of some applications. or other types of user-defined extensions. So the motivation for this project is a number of issues that people who build large systems based, multi-user applications based on the current file system have. Things like that system administrators, to install an APL application that uses component files, you have to get your corporate system administrator to create a file share. And all of the APL users essentially have to have full access to that file share and all the files in it to be able to do all the file operations. You could make things read-only, but really in order to create, read, replace, you have to grant full access to this file share. And of course, we do have access matrices, but they only apply to the access to the files that goes through the quad functions. So somebody can open a component file in Notepad or VI or Emacs. They can read all the credit card numbers that are in there because they're not that hard to find. Or they can, in fact, edit the files. I know we have at least one customer where their system administrators make a habit of opening component files with VI and making configuration changes to the system. And of course, occasionally they get it wrong. And so this is an attempt to sort of block off all that kind of unauthorized activity or give you an opportunity to do that. The current DCF is also more sensitive to network reliability and performance than one would like. If you have a network that's going up and down, you'll get interrupted sessions. In the worst case, file damage, at least before we added the file journaling features to APL. But in particular, the performance of file holds and locks can be quite bad. If you have a lot of users going over a LAN trying to lock files, there's no queue. They're trying at random to grab locks, and the performance can be very variable. Jeff's looking very questionable. Sorry? Okay, so Jeff is saying that on Unix servers that's not much of a problem, and I think that's probably correct. The first version of this is really targeting Windows local area networks where we know that it will give immediate benefits on all of these fronts. On Unix it's going to be a bit harder if you're already running server-side Unix clients. They're not going over the network to do most of their work, so the DFS won't be as competitive, if you like, in that situation. Yes, Richard?
Well, you said on there that the access matrix only applies to the DFS.
Yeah.
But to circumvent that, you would have to be on the server, would you not? The client still wouldn't be able to see the files.
Sorry, with the DCF?
If you're sat on a client machine,
yeah,
you don't have direct access to the files.
Not with the DFS, no. That was the problems with the DCF on the previous slide.
Got you.
Yes, the DFS solves the problem. So this is like in one of those personality tests. This is the previous slide where everything's been turned on its head. So the DFS only allows access to files through these sockets where we can control exactly what's happening. Access matrices have absolute authority, and in fact, you can add additional constraints. You don't need to set up file shares. You may need to get your system administrator to allow connecting some sockets over the network, but that should be less of a problem. And then there's this last bit where the DFS does its best to recover automatically from network glitches. Even server restarts. In fact, one of the requirements we're working on for the next release is that you'll be able to reconfigure it and restart the server, and the clients will automatically figure out that there's now a different pattern of file servers on the server side that need to be connected to. And file holds are queued by a separate process, which gives significantly enhanced performance for large multi-use. Then there are some additional benefits that come from using this architecture. We have this monitor where we can go in and see, who's holding this file, who's tied this file, and kill them if you want to get rid of them. But then, I can't demonstrate that now because it's not working yet, but we'll have performance monitoring facilities so you can see, which users are hogging the server, which files have the heaviest load, should we break them up, should we spread them over more server processes to improve the performance. And then We expect to, by the end of the year, once we have some changes that are going into 13.2, to be able to do online backups. So without taking the system down, without even pausing it for more than a few seconds, you'll be able to take full and incremental backups while the system just continues to operate, at least for the component files. If you're using native files, then we can't use Richard's magic bag of tricks to essentially implement a primitive transaction system. And there may be a longer pause, maybe for a minute or two, depending on the load on your native files before the image is synchronized. And as you've seen, we can make more than one connection from a client session, and you can write multi-threaded client-side applications that independently use the DFS. In the longer term, we expect to be able to do quite a bit to make the performance even better. We can start compressing the data that goes over the network. Maybe we'll even put compression into the file system and cache pre-compressed data in the server. We can have stored procedures. These things should be able to, if used well, really improve the throughput of your applications. And then there are sort of disaster recovery and transactional things that we may be able to add in future releases as well. So you could have a DFS running here, and you could have one running in the UK, and it could be mirroring all the transactions at a logical level, so that you know that the remote backup you have is always a logically consistent copy of your file system from only a few seconds ago. Right, so on to some more practical details of how this looks when you're operating it. Obviously, that picture we saw at the beginning, there's lots of different boxes. You can start different numbers of them. The configuration is all held in a set of XML files that look like this. This is the master configuration. I don't think we want to go into much detail here, but there's a lot of control over how much logging you want. So whether all the different error logging messages that the system can produce are classified in a huge number of different categories, and you can decide which ones you want to have going into the log while the system is running. You can decide the default journaling level and checksumming that you want to use. I can't remember what permissive shares are, but it's something, some, I think, option related to the erase a file if share tied, yes. So that's something that SHAREFILE AP could do, I think, yeah. How many times you want integrated Windows authentication to retry if there's some kind of problem, because if you set that number too high, then your user will get locked out of the system in about a microsecond. And so on. Lots of different timeouts for how long you want the client to wait before it decides that the server's gone to sleep. Then there's a configuration file that controls this partitioning of your file system, and so you can have different folder prefixes, and you can set up different sets of server processes to handle them. So this main folder here is being load balanced across 3 of those processes, whereas this test folder only has 1 process handling it. And then there's the file that controls how many of those processes you actually start and which ports they're waiting on and so on. So all of that stuff is configurable to whatever your system administrator, which ports they want you to use, etc. And finally, there's a notion of user roles, which can be used to add additional constraints on what users can do in addition to that which is controlled by the file access matrices. So you can set up a bunch of roles, and then you can assign the users to have different roles. So this is showing a user administration screen. You can either, if you have an application, you might want to just edit those XML files yourself because you've already got some kind of user administration system built into your application. Or you can use the DFS, which will have, of course, my server-based GUI to add users and assign roles to them, etc. Right. So you have to log into the DFS. You can't run as user number 0 as you can under Windows and get full access to everything. You have to log in as an actual user. The DFS has a table of valid users, and it can either it can combine both user IDs that it validates itself, or you just hand the validation over to Windows and say, I'll accept anything where I can identify the Windows user, but by the way, I have this list of people who are allowed to actually log into the DFS. So it's not necessarily everybody who has a Windows user ID who can connect to it. Right. So this is all written in nearly all written in APL. And you might think, how can it then possibly perform well? The numbers we have so far show that although virtually no time has been spent so far on the project doing any form of optimization, it's already in the real world outperforming the DCF in real applications. It's sometimes, in the tests that I've been able to do myself, it's sometimes slower on reads because there's no form of caching implemented at the moment at all. It will always ask the server to read a component. We could use some hashing, checksumming, etc. But it is already significantly faster on most write operations because all of the file ties on the server side are exclusive ties. So it's going through code in the quad F replace, for example, which is optimized for exclusive ties, and which is very, very much faster than the shared file operation code, particularly if that shared file operation code was running over the network previously. The performance is also much more stable. I'll show you some numbers on the next slide. The current target for version 1 is to make DFS something which competes with Windows LAN file access. But in the long term, of course, we want to be competitive also on the Unix platforms, even though that's much harder when you're competing with something where the clients are already running on the server. So I didn't really have time to do enough benchmarking. I tried last week, but I ran into some problems. What this showed, this is our TPS benchmark. So this is basically what we're doing on each client is hold the file, read a 10K component, write the data back, and release the hold. And then running this with 1 client, 2 clients, 3 clients, 4 clients. And in each cell here is the best time that was observed, the average time that was observed, and the worst time that was observed. And there are 2 interesting things, really. One is that the DFS is consistently close to twice as fast. This was on, I just had a little i7 server and an i7 laptop, my own laptop that I was running this on a wired LAN connection. There's 2 things. The DFS is consistently close to, well, somewhere between 1.5 and 2 times faster. But if you look in the last column here, you'll see that the variation in time is actually getting smaller with the DFS, whereas when the quad functions on the LAN, I think in particular it's the file hold operation that's causing the big variation. We're starting to see extreme variations here. I was trying to do a column with 8, and I found that I couldn't get reliable numbers with the DCF because it seemed that some of the clients actually never got the hold. So I was getting some numbers which were too good for the DCF for some of the clients, and some of the clients simply weren't doing any transactions at all, whereas the DFS just degraded another little bit. It reaches a peak here of about 70 transactions per second, and then it fades a little bit. But it's essentially staying stable in terms of how many transactions it can do per second. We'd had one look at doing compression in the initial project, and we found that on the LAN it slowed things down. But as soon as we went to just a Wi-Fi connection rather than a LAN, we saw some small speed. It was very minor speed up, not worth doing in the first part of the project. But if we can actually start caching on the server side pre-compressed components, then we won't get the performance hit of compressing the data on a read. We can just send the zipped file down the wire. So this will probably be some kind of configuration option, maybe when the client connects, it'll test the latency of the connection and the bandwidth, and then it'll decide whether to do compression or not. Right, so differences between the DCF and the DFS. There are some. Actually, the second one there shouldn't really be listed here because this will, I don't think it's optional right now, but it will be optional, right, Brian? It is already optional. Okay, good. But you cannot log in as user 0 here and gain full access to the file, as you can do under Windows. And as I think most people who use the Windows file system, because there is no real security to be had from the access matrices, they tend to log in as user 0 and just ignore access matrices on Windows at the moment. Right, so yeah, I don't know how many of you, this is actually a bug and it's going to be fixed in version 13.2, right, Richard? Yes. At the moment, quadflib doesn't report exclusively tied files on Windows, because quadflib is unable to open the file and determine that it's a component file. If you didn't know that, you may want to go back home and fix your utility functions, or just wait for 13.2 and it'll be fixed. There's a small difference in FIST that'll also be removed because when asking people who were using this, they all agreed that turning a tie into an update operation on the file wasn't actually something they wanted. So we won't be recording, at least not optionally not recording the last tie time because it turns a tie into a write. With the DFS, you can tie more than 253 files from the same client connection. I don't know if that occurs in practice, but it did occur in testing. And here's one thing you might have noticed if you were really awake when I was doing the demo, was that DFS file holds are not released on return to immediate execution. So I went q.fhold1 and I hit enter and returned to immediate execution, and that still blocked the next file hold that I wanted to do. And we spent a bit of time thinking about whether we thought that was a bug and whether there was some way we could detect a return to immediate execution. But we decided that it's a feature, it's not a bug. It's actually more helpful in most debugging situations to have the system working this way. It is so frustrating to be trying to debug something to do with file holds and have the locks released every time you return to immediate execution. You simply can't debug that stuff at all. And I think this behavior of releasing on return to immediate execution is an old mainframe thing that was really needed at the time because I think it predates error trapping. It was implemented in APL systems before they had real error trapping. So you really needed to do that to avoid the people running screaming down the corridor saying who's holding that file, damn it. Is it robust? Well, I need to thank some of the guys in this room for making me feel much more comfortable about this. The testing by the launch customer and the guys working on the project has been outstanding. It's been tested, in fact, by the people who wrote the book on destruction testing. These guys. And towards the end of the project, in fact, we were finding bugs in the component file system itself and in Conga, and it was really good. So the origins of this project, this is where I need to apologize to Carlo. I think I mentioned this at the Dyalog conference at least 5 years ago. I know he's been waiting for it. He's customer number 2 now, not number 1, as he should have been. Nick actually finally started work on this back at the end of last year, and then 3 APL programmers have been working on it a bit since then. It went into production 10 days ago, I believe, and some of the guys involved in that project are here today, and I assume that means it's going well. So, to wrap up, the road map. So before we make this generally available, there are going to be a couple of launch customers, and then hopefully we'll make it available sometime in the middle of next year to everybody. We have some folder management functions. The native file stuff is for customer number 2 and hasn't quite been finished yet. The online backups, we discovered that we needed some support in the component file system itself to allow us to get a logically consistent snapshot of an entire file system. So Richard's doing magic on that right now. And this business I mentioned of hot configuration switches, taking down servers, bringing them up, changing the configuration on the fly while the system is running, with the exception of the hold server. In the longer term, I think a lot of the next couple of releases will be focusing on performance, getting caching working so that we're more competitive compared to also on reads. But then we can start imagining extensions to the file system, like being able to read 10 components at once in a single network transaction, or in fact running that transaction code, the hold, read, replace, unhold, entirely on the server side, if you needed to do some form of equivalent of a stored procedure, and allowing maybe not a client to upload a new transaction stored procedure. Well, maybe if you have the correct rights, but at least allow the system administrator to make server-side stored procedure functions available to everybody, and compression. Transactions, we have some ideas about that. You could have a default mode where a quad F hold initiated a transaction and the unhold was a commit. That's way out in the future. And of course the mirroring and disaster recovery features that I mentioned on the way. So the DFS is going to be driving a few new features in the file system, some of which, as many as we can, we'll probably put into the component file system itself, as we've done with the fhist function. And we certainly want to make it possible for you to write your applications in such a way that you can run them with a DCF in a small standalone environment, and then maybe you run the DFS in a corporate secure environment. The backing storage for this is 100% ordinary DCF files. I think we will put a restriction on, if you want to use the online backup feature, you will be required to use only the so-called large span files, the 64-bit files. But hopefully most people are already migrating to them. Yes? Yes. So there's no file conversion to move your component files in or out of this system. Yep, availability. We are looking for a couple of additional early adopters. So if you think the features of this are exactly what you need to improve the performance, reliability, security of your application, please do contact us. We're really only targeting Windows servers for the launch phase, and we're imagining that after we've been through maybe 3 or 4 launch customers, we'll be ready to really roll this out with documentation and operations manuals and so on in the middle of next year. And as Gitte mentioned in the opening session, it is really our philosophy to make sure that all the components that you need to build a modern application are bundled with the APL system. So, we bundle David's editor, David Liebtag's array editor, because we like it. We don't think you should buy that. We're happy that we've been able to bundle, RainPro, New Leaf, Conga. But this is really an enterprise product that has a lot of cost on our side. We need to provide support round the clock, basically, for people who are operating this. So this is not just going to be bundled free with the system. We haven't decided exactly what the pricing will be. Please let us know if you're interested, because the more of you who say you buy one, the lower the price might be. And that's all I had to say. I'll leave this picture up to inspire you to ask 6 minutes worth of questions. Lars.
I have 2 questions. First, I've seen a use for this in SimCorp where we will kind of protect our binaries. As it is now, we have a folder where everybody can just update the binaries with their new version and then passing our software management control, and we just find out afterwards. So an interesting aspect for us is if you can take a local file and then pass it on to the server and then create it as a file in the remote directory. That's question number one. And my question number two is that although there is a nice GUI for doing this, user management, do you have any plans of doing this so we can do it on the program control?
Yes, I forgot to mention that really. There are already functions to, for example, add a user that are being used by the launch customer. With respect to the first question, I neglected to mention that you configure it to say //D1 and D2 go to the file servers. If you tie a file with any other prefix, it just uses the quad functions to tie it locally. So you can in fact combine the use of local files and remote files. We don't have a copy function as you suggested, but that could clearly be added. And we could allow you, the system administrator, to write some APL code that you injected into the server side to validate what happens. So when they commit the software to your source code repository system, you could actually run some automated code inside the DFS to play Big Brother on them. Yep. Nope. Okay, well, thank you very much.